Hello. Good morning, everybody. I am Dr. P.V. Sasi. I like to share a topic in organic chemistry, particularly synthetic organic chemistry, retrosynthetic analysis. This talk is a part of Maharaja's College Chemi Lumin lecture series. Chemi Lumin is a general platform formed by all teachers worked in the Department of Chemistry along with the present faculty members. Students can access talks on different subjects of academic and general interest. The title of my talk is Retrosynthetic Analysis. So, retrosynthetic analysis or retrosynthesis. What is retrosynthesis? Retrosynthesis is the reverse of a synthesis. That is, thinking in the reverse order. Say, what all process you have adopted for the synthesis of a molecule in question, you now just to reverse the track. This is the concept of what is called retrosynthetic analysis or retrosynthesis. Before going ahead with these topics, a knowledge of synthesis is very important. So what is a synthesis? As you know, synthesis is a process of obtaining a compound after a series of chemical transformations starting from very simple common substances or substances in the elemental state. Synthesis is a methodology of getting a compound starting from very simple common starting material or substances in the elemental state. It may be associated with large steps of reactions. For example, let us see the synthesis of D. A, B, C and D. Let us take an example of synthesis of A, a synthesis of D. This is now called the scheme of synthesis of D. This is what is called the scheme of synthesis of this. In organic chemistry or in chemistry, it is a general practice to write the route of reactions or what is called the scheme of reaction, which implies the starting material, different intermediates and also the products. Moreover, it also implies the different steps involved in the total synthesis. So this is a 3-step synthesis. Step number 1, step number 2 and step number 3. The same idea can also be represented in this manner. This is also a scheme where the steps involved is mentioned, starting material is also given, final product is also given. So, this is what is called the synthesis or the scheme of synthesis. Now, this synthesis is possible, or we can write this scheme only if you know the starting material, the intermediate B, C, etc. Then, if you know nothing about the starting material and the steps involved in the overall synthesis of a new molecule, now the retrosynthetic concept will help you to identify the various intermediates and the starting material. Now, in this particular scheme, say you may get to C, a D from C. If you start from C, you may get D. But we cannot just call it as what is called a synthesis of D. Then, even if you start from D, you make it a D via C. In this particular case, here also we cannot say it is the scheme of the synthesis of D. But starting from A, ending at D, the overall process is what is called a synthesis. Then, the conversion of C into D or B to D via C may be called as preparatory state or preparation. So, what make a preparation differ from or a synthesis differ from a preparatory stage? Here, you know that conversion of C into D may be taken as a synthesis if C is the very simple common substances. But in this particular case, C is not a common one, simple one. D is again not a simple one or common one, but A is the simple common substance. So, this overall process is what is called a synthesis, while the intermediate states or the others are called what is called preparation. Then, as we have discussed earlier, this is possible only if you know the starting material A and intermediate B, C and the final product D. Then, if you know nothing about the starting material and also the intermediates, retrosynthetic analysis will help you to identify the same. That is, you, according to retrosynthesis, think in the reverse manner. Think in the reverse manner. That is, you take D, then from D, you dismantle the D, disconnect the D, or fragment the D, then you make it C. And this is the sign used for dismantling, disconnection, or fragmentation. You make it C. But you can see that in this particular case, C can also be further disconnected to get to B. Disconnected to get to B. And B also can be disconnected to get to C, A. And finally, you can see that A cannot be further disconnected. A cannot be further disconnection. So, the conversion of A into D, starting materials into product, is what is called the synthesis. While the reverse process is what is called a retrosynthesis. Retrosynthesis. So what is retrosynthesis? Retrosynthesis is the reverse process of a synthetic route. Now, for example, suppose we want to make a radio. What is the best method of making a radio? The best method available is, if you know the components, if you know the parts of the parts, you collect the components, assemble together, you will get a radio. But you can see that you cannot assemble the whole components in a single steps or single attempt. You have to assemble the parts in a certain order. So, in synthesis, there is an order. In in retrosynthesis there is also an order. But these two are in the reverse manner. Reverse manner. Say, here there arises a problem, or the synthesis is the obtaining a compound starting from or beginning from a fine, very good starting material. Retrosynthesis says that in order to identify the starting material, you have to start from the end or start from D. Say, if the final molecule is in your hand, then what is the need of retrosynthesis? So these statements may appear to be quite contradictory. But there is nothing contradictory in this concept, because retrosynthesis is only a concept, an imaginary work. It is only a concept, an imaginary work that is operated only on the mind of a chemist, or can operate only on a blackboard or on a paper. But synthesis is the real part. That is, one has to execute the work in a chemical laboratory. Then, another way I will make you clear about the concept of retrosynthesis. Suppose a carpenter wants to make a bench. Then, the picture of the bench comes to his mind for the first time. If anybody who wants to make a bench, definitely the picture of the bench comes to his mind. Because without this picture, he cannot make the real bench or bench according to his intention. Now, the image of the bench is formed in his mind. Then, this image will help you to determine to assign the quality of the bench. For example, the length of the bench, the height of the bench, the breadth of the bench, the color, etc., etc. After fixing all this one, you can do what is called the real making part. Then, according to retrosynthesis, a compound can be prepared, or a substance can be obtained or may be prepared if you know the components. Say, according to the present, say, analogy or example, suppose one wants to make a bench. Immediately the picture of the bench, the image of the bench comes to his mind. Now, you are going to disconnect the bench, just like what is called our radio. We are going to disconnect the bench. The purpose of disconnection is to identify the starting material as well as the route or the various stages involved in the say disconnection process or the real making process. Say, suppose we disconnect the bench, cleave the bench like this, and this is a sign used for disconnection in retrosynthetic analysis. Then this is the arrow that we use to represent the disconnection. Then if you cleave the bench like this, you will get two parts. You will get two parts like this. Two parts like this. Now, these are the components. Component number 1, component number 2. So, you get an idea of the components. Now, the only job is to join these together to form the bench. So, is a this is what is called an analysis or retro aspect. Retro aspect. But assigning this or identifying these components in real making of the bench, you have to go to what is called a wooden shop or shop, ask about these pieces. You can see such pieces are not available. Such pieces are not available. So, you cannot make the bench. So, imaginary cleavage of the bench or dismantling of the bench in this manner, even if we get two components, is not a reliable one, is not an acceptable one. Say, this is what is called an unacceptable as a way of cleaving a molecule. At the same time, we can cleave the molecule in another way also. Cleave the bench in another way also. Say, this is the position of the cleavage. Now, you can see that here you will get two parts. These are the components resulting from this type of what is called cleavage or dismantling. Here also get two components. But it is clear that these components are more reliable than the other one. Or the retrosynthetic concept of cleaving or dismantling or disconnecting the object in this manner is always acceptable, reliable than the other one. That means we cannot divide the molecule at any position. We should divide the molecule, disconnect the molecule in such a way that there is what is called unavailable reaction which used to combine in the real synthesis. Now, so this is a way of what is called cleaving this bench, acceptable cleavage of the bench. Or we can see that now cleaves like this, you get two parts, two parts. Two parts. Now, these parts, wooden pieces, we can make it available from on wooden piece. On wooden piece. Wooden piece. And it is made available from wooden logs. Wooden logs. Now, these wooden logs may be obtained from what is called a tree. What's called a tree. And again, the tree can be identified from what is called a forest. What is called a forest. That is, your attempt is to make the bench. In order to make the bench, we want to know what are the components. In order to identify the component, we draw a structure of the bench on a blackboard. Subject to what is called retrosynthetic analysis or analysis part, where the molecule, the bench is cleaved in this manner, two components. The components may be obtained from wooden logs. Wooden logs is part of what is called a particular tree. Tree can be identified from the forest. So, the retrosynthetic analysis is now over. retrosynthetic, the reverse thinking, retrosynthetic analysis is now over. Say, but after this you have to synthesize the molecule, that is the synthetic the part. For synthesizing or what is called making a bench, you have to go to a forest, identify a suitable tree. The tree is cut into pieces or wooden logs. From these wooden logs, you make these two components. Combined together, you will get a bench. So, this is the real synthetic part which one can execute in a workshop. And this is the what is called the retro aspect or retrosynthetic aspect for identifying the components. Now, what is the relevance of this type of, say, example? We can see that. Let it be connected with our, say, chemical world. Say, this is our compound D, chemical compound. These are reagents, or these are reagents, starting material. Say, here the forest stands for large number of reagents. Thousands of chemical reagents are available. Or this forest stands for the storage of a chemistry laboratory. The storage of a chemistry laboratory. In order to synthesize a molecule, you have to go to what is called a storage, chemical storage, select what is called the reagents, particular tree. Then, this reagent can be modified. The reactivity of the molecule can be improved by modification. From this, you make it only one component. Then, you repeat the same, take another reagents, make the other components, combine together, you will get the final molecule. So, retrosynthetic analysis is what is called an imaginary portion, usually operate on a molecule in question. And the aim of this retrosynthetic analysis is to identify the correct starting material and what all process we have adopted during the analysis part. In real synthesis, you have to just reverse the process. So, these retrosynthetic aspects help us to identify the starting material. Moreover, the stages, the better way, easy way of synthesizing this molecule. And this is the most economical one as well as the eco-friendly method. So in olden cases, we were practicing what is called red chemistry, because a chemist is always bothered about what is called the compound, getting the compound in question. He is little bothered about the byproducts. Say, these byproducts may cause very hazards to the even nature, or it may difficult, or it may cause several environmental problems. But nowadays, we are approaching the synthetic methodology was being transformed into what is called an environmentally benign synthesis, or eco-friendly synthesis, or green synthesis. When we are doing green synthesis, you will get the final product with least impact to the environment. The case is another way. Let us see the remaining portion as our video part 2. Thank you.